kinetics. We are dealing with determination of order, and this will be our second method. We know that there are four methods for finding order of a reaction. We have already seen the first one, integrated method, in the previous module. Now here we will study the isolation method for determination of order of a reaction. But first things first, you need to understand that this isolation method is also called as Ostwald isolation method. So if they ask you questions on either of the two, do not get confused, it's one and the same. Now here, understand that this method is useful for multiple reactants, unlike the previous method. The integrated method was only useful for one reactant, but that's not the case here. So I want you to consider this reaction, A plus B giving C plus D. Now here, for this reaction, the rate law can be written as rate is equal to K into concentration of A raised to alpha into concentration of B raised to beta. How many times have we done this? Now, what you need to understand is alpha plus beta is overall order of the reaction. For that, alpha and beta has to be found. So here's the basic principle behind this isolation method. The concentration of one reactant is taken in excess. Hence, its change in concentration is almost constant. This is pretty much like the pseudo first order reactions that we had seen. So here, we take one reactant, much more in excess. Now what happens because of that is that the variation in rate corresponds to the concentration of the reactant which is small, the reactant which is not taken in excess. Just think about it, my dear students. Suppose if B is taken in excess, then the concentration of B will almost be constant, which means that the rate will depend only on the concentration of A. As A will decrease, the rate will decrease. So let's understand that better. We know that for this reaction, this is the rate law. But if we have a large excess of B, we can say that rate is equal to K dash into concentration of A raised to alpha, where K dash is nothing but K into concentration of B raised to beta, all the constant terms taken together. Now here, if the concentration of A changes, the rate changes. All I have to study is how much is rate changing when the concentration of A is changing. Once I am able to quantify that, I can find the value of alpha. The numericals on this are really very simple. Anyway, the rate depends only on the concentration of A, and hence alpha can be determined. Now we can repeat this procedure by isolating A. Now we can take A in excess and we can isolate it. We can evaluate beta in the same way. Understand that this method is applicable for multiple reactants. For example, P plus Q plus R is giving products. Now what I have to do is, first I have to take Q and R in excess, which means the rate will depend only on the concentration of P. So I can find out order with respect to P. Then I will take P and R in excess and I will find order with respect to Q. Similarly, then I will take P and Q in excess and I can find out order with respect to R. So I can use this isolation method for multiple reactants. Second thing, the order has to be an integer value. You will understand this method much better when we solve numericals on this, which are really very simple. In the next module, we will discuss a very interesting method of initial rate method. So see you in the next module. Till then, take care.